Welcome to the DIY Honda Garage channel. Welcome to this troubleshooting guide for the DTC P1192, which indicates a low voltage condition in the fuel temperature pressure FTP sensor circuit of the 2006 to 2011 Honda Civic. This error can hinder the engine control module, ECM, from obtaining accurate readings crucial for optimal engine performance. It is essential to understand the role of the FTP sensor, notably its location, usually found near the fuel tank, where it measures fuel temperature and pressure to inform the ECM. This feedback helps in regulating fuel injection and combustion processes for efficiency and emissions control. Having the right diagnostic tools and data at hand is crucial before proceeding with troubleshooting. This guide will outline step-by-step procedures to diagnose and address issues related to DTC P1192 effectively. The fuel temperature pressure FTP sensor is a critical component in ensuring that the engine operates effectively. Its primary function is to measure the temperature and pressure of the fuel, sending these vital readings to the engine control module, ECM. Located typically near the fuel tank, the FTP sensor plays a vital role in fuel management systems, helping to adjust fuel delivery based on the sensor's readings. A low voltage condition, as indicated by DTC P1192, restricts the ECM from receiving accurate data necessary for optimal fuel injection and combustion processes. Understanding the role and location of the FTP sensor will guide effective diagnostics and repairs. Before proceeding with troubleshooting, ensure that freeze data and onboard snapshots are recorded to provide a baseline for diagnostics. A variety of issues may lead to the DTC P1192 error, primarily focusing on electrical connections and the functionality of the sensors. The first possible cause is poor connections or loose terminals at either the FTP sensor or the powertrain control module, PCN. Such conditions can interrupt the signal flow, leading to erroneous voltage readings. Another likely cause is a faulty FTP sensor itself, which may not provide accurate voltage output due to internal malfunctions. Lastly, a malfunctioning powertrain control module, PCM, could misinterpret the FTP sensor data. Each cause should be investigated thoroughly, as rectifying these issues is essential for restoring proper sensor functionality and ensuring the engine operates efficiently. When encountering DTC P1192, several symptoms may manifest in the vehicle's performance. One common symptom is poor engine performance, as the low voltage reading from the FTP sensor can affect fuel delivery, leading to sluggish acceleration and decreased power. Additionally, as the sensor fails to provide accurate data, increased emissions may occur, violating environmental standards. Another symptom often observed is the malfunction indicator lamp, MIL, illuminating on the dashboard, signaling a diagnostic trouble code is present. Drivers may notice these signs as the vehicle struggles to maintain efficient operation. Identifying these symptoms early is crucial to prompt diagnostics and repairs, preventing further complications. To begin the troubleshooting process for DTC P1192, the first step involves turning the ignition switch to the on position, known as Ignition 2. Once the ignition is activated, utilize the Honda Diagnostic System, HDS, to check the voltage readings of the FTP sensor in the data list. This step is crucial as it provides immediate insight into whether the sensor function aligns with expected benchmarks. If the voltage is at or below 0.23 volts, it signifies that the sensor might be operating under low voltage conditions, guiding the technician to the next steps. If the voltage reads above that threshold, it indicates an intermittent failure, suggesting that the system may be operating correctly at the moment. At this point, checking for poor connections or loose terminals becomes necessary for further diagnosis. In this second troubleshooting step, first turn the ignition switch to the lock position, which is the initial state when the vehicle is off. After ensuring the ignition is off, proceed to disconnect the FTP sensor 3P connector, which is the connector linked to the FTP sensor. Following this disconnection, turn the ignition switch back to the on position. Again, use the Honda Diagnostic System, HDS, to check the voltage of the FTP sensor. This step is crucial, as it helps determine if the low voltage condition persists even after disconnecting the sensor. If the sensor still shows a low voltage of 0.23 volts or less, it indicates an ongoing electrical issue that needs further examination. However, if the readings change, it may point to a malfunctioning FTP sensor that requires replacement. For the third troubleshooting step, the focus shifts to measuring the voltage at the FTP sensor 3P connector terminals. The technician should assess the voltage between terminals number 1 and number 2 of the FTP sensor 3P connector, a critical connection point for the sensor. The expected reading should be around 5 volts, which is necessary for the proper functionality of the sensor. If the voltage measures at the anticipated 5 volts, this suggests that the electrical circuit provides adequate power supply to the FTP sensor. This positive indication allows the technician to proceed to the next troubleshooting step. Conversely, if the voltage reading is not at 5 volts, further examination of the electrical continuity and power supply in the associated wiring becomes imperative to pinpoint the issue. Moving forward to the fourth step in troubleshooting DTC P1192. First, ensure that the ignition switch is turned to the lock position once again. After establishing that the vehicle is off, the next crucial action is to jump the SCS line using the Honda Diagnostic System, HDS. Jumping the SCS line allows for a diagnostic bypass, facilitating a more thorough examination of the PCM's communication with the FTP sensor. Following this, disconnect the PCM connector A, which comprises multiple pins responsible for various sensor inputs, including the FTP sensor. This disconnection is vital for assessing the integrity of the signal from the sensor to the powertrain control module, PCM, without interference from other circuits. The final troubleshooting step involves checking for continuity between the FTP sensor 3P connector, terminal number 3, and a reliable body ground. This action is fundamental to ensuring that there is a solid electrical connection, allowing the FTP sensor to send accurate readings to the PCM. Conducting this continuity test is crucial, as it verifies whether the signal path is intact and functional. If continuity is present, it suggests that the wiring is intact and functional up to this point, potentially indicating that the FTP sensor itself is defective. However, if no continuity is detected, this likely points to an issue with the wiring or ground connection within the circuit, necessitating a thorough inspection and possible repair to restore full functionality to DTC P1192. After completing all necessary repairs for DTC P1192, it is critical to ensure that proper repair verification takes place. Start by confirming that all repairs made, whether it involved replacing the FTP sensor or addressing wiring issues, are effective and securely implemented. Once confirmed, proceed to clear any diagnostic trouble codes stored in the ECM, allowing for a fresh assessment of the vehicle's performance. After clearing the codes, it's essential to take the vehicle for a test drive under various operating conditions to monitor how it responds, and to confirm that the DTC does not reappear. This step is fundamental in ensuring that the solution effectively resolved the low voltage condition and that the vehicle operates without hindrance. restoring optimal engine functionality. Engaging in preventive maintenance is vital for preventing issues like DTC P1192 from reoccurring. Regular inspections of the FTP sensor can help identify any signs of wear or damage, ensuring that it functions correctly. It is equally important to check electrical connections for any signs of corrosion or looseness, as secure connections are essential for accurate sensor readings. Additionally, performing routine checks on the powertrain control module, PCM, can identify potential communication issues or software updates that could improve overall vehicle performance. By actively engaging in these practices, you can extend the lifespan of critical components and reduce the likelihood of future diagnostic trouble codes emanating from the fuel management system. In conclusion, understanding DTC P1192 and its implications for the 2006 to 2011 Honda Civic is critical in maintaining vehicle performance. Identifying the error as a low-voltage condition in the FTP sensor circuit necessitates thorough diagnostics and repairs. Checking connections, evaluating the sensor's functionality, and ensuring proper grounding are all vital steps in troubleshooting this issue effectively. By engaging in preventive maintenance practices, such as regularly inspecting sensors and electrical connections, vehicle owners can mitigate the risk of future issues and keep their vehicle running smoothly. This comprehensive approach to DTC P1192 not only aids in troubleshooting, but also reinforces the importance of a well-maintained vehicle for longevity and efficiency. Please like and subscribe to the channel. See you next time.